Hey guys. So there's two of us. There's four of you. So I think the eves are, or five of you. The odds are a little bit evened. We're the co-founders of Holonym. We've been developing a very exciting, incredible new technology called Mishti, which makes human keys real. We started off building for a very niche, specific use case for how do we make cryptography go mainstream for civic infrastructure? How do we allow people to donate crypto to politicians while remaining in compliance? How do we onboard all possible humans onto the benefits of cryptography for privacy, security, personhood, making digital human rights real? So really excited to tell you about how we went from a small niche project to a project today with over 200,000 zero-knowledge credentials, over almost 150,000 wallet users, and generating revenue. And now we're decentralizing.
So why would we build Mishti Network? It takes a lot of time to build an AVS, and I mean to build less time to build an AVS than a regular network, but still a lot of time. We built it because it doesn't exist yet. We had a big need for driving what we call human keys, which are keys derived from personal attributes, whether it's government IDs, web logins, social security numbers, passwords, biometrics, security questions, anything related to keys or identity. We need a way to generate secure entropy, secure randomness, something that can be used as a key to secure assets, to secure identity. So there are a couple of related problems to this across our stack. So we have one wallet product, we have one zero-knowledge identity product. We all needed a way of, both of these products needed a way of driving keys based on personal data. So this is kind of a problem that we've seen all over, not just in our own products, but we only realized it once we built Mishti Network and we're like, oh, actually, like human keys, like this solves a bunch of the problems in onboarding and ZK identity and privacy, et cetera, which are some of the biggest problems in our opinion in Web3 right now. And as far as the market opportunity, there's the whole idea of the fat wallet stack. We think that the wallets of the future will be built on Mishti Network, because we built a wallet on Mishti Network and it just works so much better than building a wallet in a standard way. So driving keys from not just web accounts, but also passwords, biometrics, security questions, like this allows a new level of cross-device compatibility, cross-DApp compatibility, just like better UX, better recovery, and better decentralization than before. Wallets are increasingly gaining market share. Like the FAT protocol thesis is kind of ending as L1s become more commoditized and L2s become more commoditized. Infrastructure is just not taking all the fees now. It's who has the users that's taking the fees. This is increasingly becoming wallets, and there are going to be multiple wallets, and we think the best ones will be built off of Mishti.
Yeah, so we're going to run you guys through the architecture, but I think we're a little fast on time. But like the TLDR is we're using verified Shamir secret sharing, where operators basically are elected to compute something called the verifiable OPRF, oblivious pseudo-random function, and then operators are paid out for each successful computation. And there's all sorts of fancy mathematics happening on the back end. So the use cases are pretty simple, secure and simple logins, so being able to take a JWT from some sign-on method and be able to derive a key from that. Or even more exciting, being able to take, say, for example, a biometric signal, like a face, voice pattern, maybe even like a BCI thought pattern, being able to derive a key from that. And this is all really cool because you can do all sorts of really interesting programmable privacy and we've built a wallet on top of this. Go-to-market's really simple. We're following the fat wallet thesis. Mishti Network allows us to have many white-labeled versions of this type of wallets for other dApps to do DKG. We've seen some great candidates for BD here at this conference. So tokenomics, OPRF computations, you get paid. If you're doing biometric challenges for wallet recovery, you get paid. If you're doing view and key requests for compliance, for example, to prove that somebody has passed a compliance check or a sanctions check, you get paid. And if you're performing ZK identity proofs with the Prover Network, you get paid. So we're Mishti Network. Check us out. There's a lot more information. There's a great post on the mathematics on the Ethereum Research Forum. Would love your feedback, and we're really excited to be here today. Thank you so much.
How about your tokenomics? Like, how is your token, or I guess you're planning to do a token. How is that accruing value?
Yeah, so similar method. Like in order to make payments to the network, users pay in the token. So it's essentially a fee token. In order to compute oblivious pseudorandom function, if you're like driving a key from from social accounts, from email, or if you're doing the compliance requests, if you're using basically any function that Mishti network does, you pay the network in the token.
On that, on I think the last slide, you're like, you basically do any of these things, like the operator gets paid. I think maybe can you walk me through like where that comes from? That's where I'm very confused on that. It seems really great, but I'm very confused at like that flow.
I can take this one.
Okay.
Yeah, so we first started off as a ZK ID protocol. We were doing ZK identity proofs for using KYC. And we wanted to find a way to scale beyond about the 200,000 credentials that we were driving. And so we thought, how do we get keys in the hands of users really easily and simply, and maybe can we use identity proofs for that? So the way we're thinking about it is wallet users. Any other wallet that's embedding this for DKG, for universal, say like sign in across devices. So like think of kind of like Web3 auth, but instead of sharing the private key with the app, it's a private key that's retained within the network, and you can go cross-device with that. So that's where we think it's going to be really competitive, specifically for wallets that need this sort of service, or other types of dApps that need really simple and easy onboarding. So kind of thinking of it like as like the go-to-market in general for the ultimate wallet protocol.
To answer it on a more granular level, like as far as how the payment happens, like the tokens will be given by whoever's querying the network. We don't want to introduce that UX friction on the end user because like we don't want them to have to like buy Mishti tokens in order to like use the wallet. So we have this concept of a relayer where the relayer is like doing this on behalf of the user.
And just further on that, like who's actually paying? Is it the people white labeling this solution? Obviously, you don't really want the end user, me using this, having to pay to use the service as the friction, or is it, so your like target economic client dApps who are willing to pay for it?
Yep.
Yep. So yeah, we have this aggregation layer. So people that are performing aggregation, whether it's our own wallet that can be white labeled, or other dApps that are putting this in the back end for, say, key recovery, simple sign-on, or other wallets that are requiring some other form of key derivation besides
Maybe one quick question from the operator side. If we were to kind of onboard Mishti, I saw there's like different nodes. You mentioned the relayer node. There's also a prover node. Would we need to run all nodes? How does that kind of work? Can you run me through that?
Yeah, so you just need to run one type of node, which is the prover node. We've now since named it to multiplier node, but yeah, same thing.
Okay, gotcha. Thank you.
Where is the parts of the secret story, and how do you distribute it between nodes?
Where's the secret stored?
Yeah, where's the parts of the secrets that you split in are stored?
This is a great question, it's a fun answer too. So we use, in some sense, standard Shamir secret sharing, and the secret's never reconstructed though, so we use a threshold protocol to actually compute on it. Now the question is, what happens when nodes are added and removed from the network? When nodes want to leave, we want to make sure that like we're not just like keeping part of the secret share with them. So we do a resharing protocol where nodes can be added and removed permissionlessly, and then the old shares are invalidated. New shares are now valid, but it's for the same key. So the key stays the same, but we've kind of rotated the individual shares so that each epoch we can retain the security of the network. And then there's also another concept of a semi-trusted node. So collusion is a big issue in MPC networks like this, where it's hard to have attributable faults. It's hard to say, okay, this node did a wrong thing, we can slash it. So there's this interesting concept of a semi-trusted node where you can actually split, because of like this linear homomorphism with the secret sharing, you can actually split the secret not just within a Mishti network, you can have a totally separate network or even like individual node that's independent of Mishti network, so that if Mishti network colludes, it will still be fine as long as that device or that network is not colluding. So it can be kind of split between Mishti network and another network that's not communicating at all with it.
Okay, thank you.
Thank you, gentlemen.